Welcome back, everyone. So all the sections that we've been talking about lately have been about systems of equations in one way or another. We talked about systems of linear equations, we talked about matrices, and then we had one lesson on systems of nonlinear equations. And to sort of wrap up this whole topic, we've got this one lesson on systems of inequalities. And this is probably going to be a pretty short one. This might be the shortest section of the semester, in fact. So let's get started. Let's see how it goes. All right, so this is about systems of inequalities. And, we've had systems of equations before where they have equal signs. And in this lesson, instead of equal signs, they're going to have inequality symbols. So it could be less than, it could be greater than, it could be less than or equal to, it could be greater than or equal to. And what we do with these, we can graph regions defined by inequalities or systems of inequalities. So we'll be drawing some pictures, we'll be drawing some graphs, and I really think that this topic is best shown by example. So I have a few examples to show you that I'll do for us, and then we'll do some example problems together. But what do I mean by graphing regions defined by inequalities? So, example 1. Let's talk about the graph of y greater than or equal to x squared. So, first of all, we know what the graph of y equals x squared looks like, right? Here, side note. The graph of y equals x squared is parabola, passes through the origin. Okay. So just a reminder, I mean, that's just a rough picture, but yeah, that's what the graph of y equals x squared looks like. That's if it's an equal sign. What do we do when it's greater than or equal to? I guess in words, what do we think this describes? Well, it says y is greater or equal to. So it could be equal or greater. So what would it mean for y to be greater than this curve, like greater than x squared? It's going to be the set of all points on the parabola or above it, right? Because if y is greater, we think of y coordinates as being vertical, right? I mean, we have the y-axis. So if y is greater than the curve, that means that it's above it. So we could draw this as a region, and it's going to be a region that we shade in. So it's going to include all of the points that are on the parabola. So we can kind of start with that same picture that I drew to the side. Okay, it includes all of those points and everything above it. So, look at every point in the xy plane and ask yourself, like, is this above the parabola? No, it's not. Is this above the parabola? No. Is this above the parabola? Yes. Is this above the parabola, right? Everything above it. So you can shade in this region. And that is the graph of y greater than or equal to x squared. I'll write it next to it. It's not a system of inequalities. It's just one inequality for now, but we'll get to some systems soon. So that was example 1. Example 2. the graph of y less than x squared. Let's think about this. It should be everything below the parabola, right? So it does not say less than or equal to, it just says less than. So it should be the set of all points below the parabola, because it's less than the parabola, but not on it, right? Because it does not say equal to, it just says less than. So let's try to draw this. What is this going to look like? So I don't really want to draw the parabola itself because those points are not supposed to be included in this set, the set of all points below the parabola. We could still draw the parabola as like a guide. So maybe what would be a good idea is to draw it as kind of like a dashed line. Okay, now I know that sometimes in math we use dashed lines to be an asymptote. This is not an asymptote. Okay, it's just a guide for the rest of the picture. I would like to shade in the region of all points below the parabola. So I'm thinking like everything down here gets shaded in, right? So it's a pretty big area. But what about like points over here? These get shaded in also. Even like where I'm pointing right now, this should also get shaded in because it is below the parabola, because this curve, this parabola keeps going up and left forever. So like a point over here is technically below the curve, and a point like way over here is also below the curve because it keeps going up and right. So we really need to shade in a lot, and we wind up shading in kind of the opposite of what we did in the previous example. Everything in the xy plane that is below the parabola. How does that look? Yeah, it's all of these points. You pick any one of these points and it's going to satisfy this inequality. For example, we shaded in over here where the point 4, 1 is. And you can check, like, does the point 4, 1 satisfy this inequality? X is 4, y is 1. Yes, because that would say 1 is less than 4 squared. That's true, so it should be shaded in. So, yeah, that's the graph of y less than x squared. So those two examples were just a single inequality each, but we'd really like to talk about systems of inequalities. So for example 3, let's say we want to graph the solutions to the system y greater than or equal to x squared, y less than x plus 2. So I'm going to still do this one for us. But this is the first one we've gotten to that's actually a system of two inequalities. Now, remember, we want points x, y that satisfy both of these, not just one, right? It's a system, and we use that little bracket to the left of it to indicate that both of these things are supposed to be true simultaneously. So we only want x, y that make both of these true. I mean, the first one says y greater than or equal to x squared, and we already drew that in example 1. So I kind of know what that region looks like, but we also need y to be less than x plus 2. So let's start a graph and let's see what we can figure out. How about this? Let's draw that parabola as a dashed line again, because that seemed to work on the previous problem. We know this problem involves that parabola because of the first inequality, so let's just start with that. Okay, that's pretty good. Okay, what does the second one mean? Y is less than x plus 2. Well, if, here, I'll say for y less than x plus 2, we want all points below the line y equals x plus 2. So maybe phrasing it like that helps us understand what this inequality means. You know, can we draw the line y equals x plus 2? Yeah, that's a line with a slope of 1 and a y-intercept of 2. So it looks something like this. I'm just going to draw it as a dashed line for now as a guide. So what I've done so far, and, you know, we're not finished yet, but what I've done so far is I pretty much made a guide of what this parabola looks like and what this line looks like. And now let's consider the inequality symbols. So I want to shade in the region of points that are equal to or above the parabola, but at the same time, they have to be below. Wait, did I say this right? We need to shade in everything that is equal to or above the parabola, and at the same time below this line. So equal to the parabola, but below the line. So I can actually make this a line instead of just a dashed line. And we're going to shade in the region of all points that are above the parabola, but below the straight line. And that's the answer. That's it. That is the solutions to the system. And every point that we shaded in satisfies both inequalities at the same time. So sometimes it helps to think of them as what would they look like if it were an equal sign, and maybe draw that as a rough guide. But then the part that you actually shade in, or the part of the curve that you actually kind of darken in, should take the inequality into consideration. I did not draw the entire parabola as a solid line. Okay. Okay, so I want to give you one like this to try. System of two inequalities. Notice that in that previous example, the way I phrased the problem, I said graph the solutions. And that's really what we're doing. When we shade in a region like this, we're shading in all the solutions. So I'm going to ask you to graph the solutions to y greater than or equal to x squared minus 1, y less than 1. So I'd like you to pause the video for a minute and try this out. All right, so here's what I'm thinking. The first one is a parabola, or rather, I should say it's greater than or equal to a parabola. Y less than 1, let's figure out what that is. How about this? Let's do a little scratch work. Since this is scratch work, this can just be a rough picture, but I know what the parabola x squared minus 1 looks like. It's the parabola that we drew earlier, but shifted down 1 unit. So I think that the first inequality says this. This is kind of my scratch work version of y greater than or equal to x squared minus 1. But we also have this other thing, y less than 1. What does y less than 1 look like? Well, look at this. Here's y equal to 1. Y equal to 1 is a horizontal line. Let's draw it as a dashed line. And then if it's less than that, it should be everything below it. So everything below that line. This is the graph of the inequality y less than 1. So we somehow, this was all under my heading of scratch work, we somehow want to combine these two things. We need both of these things to be true at the same time. So what do we draw as our answer? Can you see how to kind of merge these together? Let's make this final answer look good. So 3, 4. All right, first of all, it's okay to draw these things as dashed lines. We understand that that's just kind of a guide to what we're going to shade in. Same thing with the parabola. All right, now what do we need to shade in? On the parabola, we would shade in the line itself and everything above it, but we also need to stay below the horizontal line. So I'm going to darken in this part of the parabola, only the part that's below the horizontal line, and then I'm going to shade in this region. And this is the region that's kind of the overlap of these two things we did in our scratch work. And everything we shaded in is a solution to this system because every point that we shaded in satisfies both of these. You could pick a point in here to check it out, like maybe 0, 0. You could verify that that satisfies both of these solutions or both of these inequalities. And you could also check that points that are outside that we did not shade in would fail to satisfy both of these. You know, it would not satisfy both of these at the same time. It might satisfy one or the other, or neither. Anyway, this is what we should get. So sometimes it helps to do this kind of scratch work where you draw them separately and then figure out what's the overlap of this picture and this picture, and it looks like this. I've got another one for you to try. Instead of graph solutions, I'm going to say graph the solution set. It means the same thing. Graph the solution set to, oh, this time I'm going to give you 3 inequalities. X plus y is less than or equal to 2. X is greater than or equal to 0. Y is greater than or equal to 0. So I'd like you to pause again and try this out. All right, so what I had in mind for this one is that first inequality, x plus y is less than or equal to 2. I was thinking, can we figure out what that looks like as a graph, the first one, x plus y? So I thought maybe what we should do is rewrite that first one as y less than or equal to negative x plus 2. All I did was rearrange it. I got y by itself. So that helps me because, right, because this is the set of points on or below the line y equals negative x plus 2. So rewriting that first inequality is going to help us out. Actually, if you had trouble with this and you got kind of stumped and you weren't sure what to do, if this helps you out, then maybe now's a good time to pause the video and give it another shot. So let's draw this. So I think we know what that line looks like. It's right. It's got a slope of -1, a y-intercept of 2, but I'm just going to draw it as a dashed line for now until we figure out which part we're shading in. So that's, slope of -1, y-intercept of 2. And then what do we do with these other ones? Imagining that with this line that I want everything on the line or below it, but I don't want to shade all that in yet. I want to figure out what do these other things mean? Well, if x is greater than or equal to 0, I mean, here's 0 on the x-axis, right? So I want everything 0 and above. So only the right half of the picture should be shaded in. And then what does the third inequality say? Y is greater than or equal to 0. So here's 0 on the y-axis. So it's only everything 0 or above. So can we combine all three of these things into one picture? I want everything that's greater than or equal to... Let's look at the second inequality. X values greater than or equal to 0. And then let's look at the third inequality. I want y values greater than or equal to 0. We're only in quadrant 1, right? These two things together are saying take the things that are in quadrant 1. And the first inequality, or the way we rewrote it, says everything that's on or below this line. So what we wind up with is this region. That's what we get when we consider all three of the inequalities. So it's a triangle. It's a shaded in triangle, a right triangle. Okay, how about one more? Let's graph the solutions to x squared plus y squared is less than or equal to 1. X is greater than or equal to 0. I'll do this one for us. This one is a little different because of the first inequality. I guess you can pause and try it if you want to, but I'm okay with doing this one for us. All right, so here's the idea. Remember, x squared plus y squared equals 1 is the unit circle. Yeah, so we're actually bringing in something about the unit circle for this one. So x squared plus y squared less than or equal to 1 is the set of all points on or inside the unit circle. The radius of the unit circle is 1, right? And when we say less than or equal to 1, we're basically saying everything with that radius or less. So it's going to be everything with that radius or inside. So we could imagine that if we only had that first inequality, I would simply draw the unit circle and then fill it in, if it was just the one inequality. But we have the other two to also consider. So let's get started. Well, I guess this whole problem seems like it's about the unit circle, so the scale of the picture doesn't need to go out very far. We could just say this is 1, -1. Right? It's kind of more zoomed in than the other problems. I don't know if we want to draw the whole unit circle. Let's do it as kind of a dotted line. Okay, x-axis, y-axis. Now let's figure out what we need to shade in. So I would like to say, the whole circle and fill everything in, but let's consider these other inequalities. So the second inequality says we only want x values that are 0 or above. So that seems to indicate that we just want the right half of the unit circle. Okay, so positive or 0 values of x. So we don't need the left half of the picture. What does the third inequality say? The third inequality says we want y values that are 0 or below. So we want bottom half of the picture. So this basically says, what I'm writing right here is not very precise, but I'm just going to say this says right half only. This says bottom half only. What happens when you combine both of those ideas? The right half and the bottom half? It means that we're doing just the lower right quadrant. So we're doing quadrant 4. So the answer is going to be this region. Because the first inequality seemed to indicate everything on the unit circle or inside, but we also had to consider the second and third inequalities, and that kind of forced us to only shade in part of the unit circle, not the whole thing. So that was it. I said this was going to be kind of a shorter section. It's really just about those kinds of examples, figuring out each inequality, just look at each one carefully, and it deals with things like parabolas, straight lines, circles, things we know how to deal with, but when you combine them together, what region do you wind up getting? So just be careful with the inequalities, if it says less than, greater than, less than or equal to, and so on. Okay, so that's going to be it, and everybody take care.